Okay, this is a course content. These are the topics I will cover in regular sessions. So first, we actually will discuss about the basic introduction, like what is Hadoop and use cases and what are the different ecosystem components and Hadoop is good for what and Hadoop is not good for. Means in which situations which we will use Hadoop. Okay, and after we'll discuss. I will discuss with you core parts of the Hadoop. So in demo class already we discussed in Hadoop there are two core components, major core components. One is HDFS and another one is MapReduce. So we'll start with core parts. First, I'll start with HDFS and HDFS architecture and how HDFS architecture will work and what are the different services available inside the architecture. What is the use of each and every service, like main node, data node, secondary main node, job tracker, and task tracker. Okay, these are the actual architectural important. So uh, and after once the HDFS theory will complete, then we'll discuss how to put the data into HDFS. So that day we discussed actually HDFS is used for data storage, right? So how to put the data and how HDFS will store the data and how to put the data from some source to HDFS. Okay, we'll discuss that things practically. So then once HDFS will complete, we'll start with MapReduce. Okay. So MapReduce architecture and how it will be work, what are the different phases available and how it will process the data, right? So basically MapReduce is used for data processing, data analysis. So how it will be analysis, how it will be process the data, okay? What are the different phases will be involved at the time of running the MapReduce job, right? Everything we'll discuss. Once HDFS and MapReduce will complete, okay, then we'll start the ecosystem components of Hadoop. So ecosystem components means basically these ecosystems are the sub-projects of Hadoop, right? So actually these ecosystem components developed by different companies like Facebook, Yahoo, Twitter. Okay, these companies developed some projects on top of core Hadoop. Okay, core Hadoop means HDFS and MapReduce. So on top of HDFS and MapReduce, they develop their own projects. The projects are nothing but we are calling ecosystem components of the Hadoop. Okay, so in Hadoop we have so many ecosystem components like Hive, Big, Scoop, HBase, Solar, Impala, Spark. Okay, Uji, Cassandra, Flume. So many ecosystem components we have. So first we'll discuss Apache Pig. Okay, what is Pig and how to install the Pig on Hadoop cluster. Okay, uh, then how to run the Pig jobs. Okay, uh, different more. We'll discuss about clearly each and every topic. Whatever the topics I mentioned here, okay, I'll discuss with each and every topic. Then once it will complete, Hive. Okay, then same Hive introduction, installation, and how to run the Hive queries. Okay, everything. These are the topics I will cover in Hive. Okay, next Scoop. Scoop also same way. Scoop to introduction and installation and how to run the Scoop jobs. And HBase. HBase introduction and HBase installation and HBase use cases. How to run the HBase jobs. Everything we discuss. Flume. As noted, and OG, Cassandra, Impala, Spark. Okay, and then solar introduction also. What is solar and how it will be work? What is the use of solar and how solar is useful for Hadoop? Okay, we'll discuss this type of things. And same thing in talent also. We'll discuss the talent. What is talent? How to execute Hadoop jobs using talent. Okay. Okay, I'll discuss in this topic. Then, how to set up the Hadoop cluster in Apache distribution. Yeah, so actually, This cluster setup will discuss after completion of theory of HDFS and MapReduce. So once theory of HDFS and MapReduce will complete, then we'll start the cluster setup. Why? Because if you want to start the practicals, if we need to start the practicals, compulsory we have to install, we have to set up the cluster. Okay. So once theory will complete, then we'll set up the Hadoop cluster. Okay. Yeah. So here we'll discuss both single node and multi node. Okay. In Apache distribution, we'll discuss how to set up the Hadoop single node cluster and Hadoop multi node cluster also, and how to set up the Hadoop cluster on Cloudera distribution. Okay. So we discussed, right, actually in Hadoop there are so many distributions. Okay. Actually, the first distribution of the Hadoop, it is Apache distribution. Apache is the first distribution. Okay. So actually Hadoop, Hadoop, it was developed by Yahoo. Then after it was open sourced by Apache. So Apache is the first distribution of the Hadoop. Okay. And after Apache, there are some other companies like Cloudera, Hortonworks, okay, Hortonworks, and Amazon TCP. Okay. Pivotal, Mapper. So these are the different distributions of the Hadoop. Okay. So but Apache is the first distribution, and all these distributions for Cloudera, Hortonworks, Amazon, Pivotal, Mapper, for all these distributions, Apache is the base. Okay, Apache is the base for all these distributions. Why? Because Apache is the first distribution of the Hadoop, and for all these distributions, architecture is same, master slave architecture only. All distributions follows master slave architecture only, but the difference is only way of working. In Apache, it is completely, we will work completely from command line. Okay. In Cloudera, we will work from command line. At the same time, Cloudera having its own separate UI, user interface. So from UI also we can execute the jobs from Cloudera UI. Hortonworks also same thing like that. Okay. But for all the distributions follow same architecture, master slave architecture only. Okay. So here, yeah, and one more important point, Apache is the best distribution for graphics, okay, and Cloudera, Hortonworks, these distributions are the best for development, okay. Most of the most of the development companies are using Cloudera or either Hortonworks, okay, but most, as per my knowledge, 90% in India, 90% of the companies are using Cloudera distribution only for development. In my present company also, we configured our Hadoop cluster on top of Cloudera. We are using Cloudera distribution presently. Cloudera is the best, okay, for development, and Hortonworks also same thing. Okay, but compared to Hortonworks, most of the 90% of organizations are using Cloudera only. Okay, so in our sessions, I will discuss with you how to set up the Hadoop cluster on Apache distribution, okay, and as well as how to set up the Hadoop cluster on Cloudera distribution. I'll discuss with you both distributions, okay. We'll set up the clusters in Apache and the Cloudera, and I'll show the difference, how to execute the jobs in Apache Hadoop cluster, and how to execute the jobs in Cloudera distribution. Discuss these things. Okay, and these are the prerequisites concepts actually. So core Java and SQL and Linux, these are the actually prerequisites for Hadoop course. Okay, so I'll discuss with you what are the core Java concepts need for Hadoop. So basically, where we can use this core Java concepts, in Hadoop there is one concept called MapReduce. So basically, MapReduce is the programming language used for data analysis, right? If you want to write the MapReduce code, compulsory you have to know some Java concepts. So total Java is no need here. Okay, core Java concepts are more than enough. In core Java concepts, what are the we have to concentrate on OOPS concept, exception handling, inherit uh, and sorry, what is this interfaces, okay, and input methods and output methods. So these are considered more than enough for writing an app code. So I'll discuss with you these concepts, Java concepts, okay, core Java concepts, and SQL commands also. So basically, SQL commands we can use in Hadoop. There is a concept called Hive. Okay, Hive is a completely query language, very much similar to SQL. If you know SQL, then you can easily work with Hive. Why? Because whatever the queries are supported reporting in SQL, the same query is supported by Hive also. Okay, uh, and next Linux. So basically, Linux it is an operating system, right? So we already discussed if we want to Hadoop is completely runs on clusters, group of missions. Cluster is what? Group of missions. We follow the master slave architecture. We counted one is the master, remaining are the slaves. So at the time of set up the Hadoop cluster, the recommended OS is Linux. In Linux again we have different flavors like we have Ubuntu, we have CentOS, Red Hat, a number of flavors. We can choose any one of the flavors. Okay, so if at the time of set up the cluster on Linux, we have to know some basic Linux commands. Okay, we'll discuss that commands also. What are the commands need from Linux and what is the use of each and every command, how it will be work and how it will be executed. Okay, everything I will discuss from Linux commands also. Okay, and and finally discuss one real-time POC. I already discussed in demo session, right? We'll discuss one POC and mock interview questions and what type of questions will ask in interview. Okay, what are okay? And from which topic most of the questions will ask and after this certification. Okay, regarding certification questions also we'll discuss. Means what type of questions will ask for certification and okay, we'll discuss these things. So this is a course content, Mukta. Any doubts?
Yeah, Srinivas, you have written real-time project explanation. Why
Yeah.
explanation? I want to have a hand-on experience with the real-time project. Why I need inspiration? I want to do it.
Yes, yes. Okay. So real-time project means here one we'll discuss project once all the topics will complete in this course content, right? So after completion of all these concepts, we'll discuss one real-time project. At that time, I already discussed in demo session, we'll take some data, real-time data, and we'll put that data into Hadoop cluster, and we will analyze that data, some our requirements. So at that time, obviously we have to write some code. Okay, so we'll get if we know okay. Actually, we'll discuss project after completion of the topics. So every topic we'll discuss practically. Okay, at the time of practicing only, you'll get hands-on experience. Okay, so for example, I'll discuss with you some Hive. Okay, at the time of discussing Hive, I'll discuss with the real-time concepts. So why? Because present I'm working on Hive. So in real time, how Hive will be worked? What are the queries we'll write in real time? I'll discuss with on real time date. So when we are start the project at that time, obviously that is real hands-on experience. Obviously, we'll get hands-on experience. Okay,
Like
are you getting
I
that?
want to, I
Yeah,
want
yeah.
because I'm new to the Hadoop, so I want to learn and then I want to implement it. Obviously, I will not be implement by myself. I need somebody's help. So I look
Hmm.
forward you as my help for making me project by my own. Like this is what I am expecting because this should be the output. Then only I will get the job. But if I'm not able to write the code
Yes,
or
yes.
not able to do the
Obviously,
project, I will not get a job.
yeah, that is obvious. Compulsory. If I will give some project, you can implement. If you get any doubts, or
No,
if you at
I
the time
need
of
a it should be like you should be a manager and I should be a developer. Like I want like help from you. Like first you just I need guidance here. Like you need to will tell me that this is the first step, you need to do this, this is the second step, because I will stuck at each and every step maybe.
Yeah, compulsory. That will be obviously I will give the support. Why? Because you don't know anything from, you just know the concepts and you know how to execute. But project means you don't have any idea. Obviously, I will explain the main first. What is the purpose of this project? How we'll start the project? Okay. Then how to get the data and how to put the data into Hadoop cluster. Then what we have to do this data. What type of analysis we have to do. Which component we have to use. Okay. If suppose for example we have to use Hive, then how to connect the data using Hive, and how to load the data into Hive tables, and how to write the code. Everything. Obviously, I will support you. That is not a problem.
Yeah, I just want, after doing this course, I will able to write something on my resume, like
Yes,
which is
obviously.
justified, which should be
Yes,
justified by my knowledge.
yes. Compulsory how to put the project and everything. I'll
Yeah,
discuss with that project. Okay, not at all.
yeah. Your voice is again breaking. Like sometime
Oh,
it goes, and I need to guess what you have said.
really? But here I'm sitting in single room. No one is here. No noise
I
is
don't
coming
know. On
from
that
my
day, the
side.
voice was very clear. I don't know why it's breaking.
So maybe I think it was problem with headset. That guy using some headset. Today I'm using some other one. Why? Because that headset was I forgot somewhere.
Yeah, on that day, the clarity was great.
So okay,
Okay,
tomorrow onwards I will use that one only. Okay.
okay.
Hmm. This is clear, right?
Thank you. Yeah.
Yeah. Okay. So yeah, distributions means you know all distributions are following same architecture, but the way of working is different. Um, I'll discuss with you when we start the cluster setup. At that time, you get clear picture. Why? Because uh, at that time we'll see that clear practically, right? So Cloudera is the important one here. Cloudera is the best for development. Okay. Uh, And we also discussed in Hadoop, there are two types of versions, right? 1.x type and 2.x. What is the difference between both? Any idea, Mukta? Hello?
Hello.
Yeah. Yeah, in demo class we discussed the difference between 1.x Hadoop and 2.x Hadoop. Any idea you have?
Yeah, I think it was something related with the one node and two nodes, something like that.
Yeah, actually, what is the architecture of the Hadoop? Master slave, right?
Yeah.
Yeah. So the difference is in in 1.x Hadoop we have one master and
And
multiple
it was
slaves.
two. Yeah, and
Yeah,
two
in
masters.
Hadoop we have multiple masters and multiple slaves,
Yes.
right? So
Yes.
why we have to use multiple masters? So
So
in
that if
1.x,
one master get corrupted or something problem, you can take the data from the another master.
yes, exactly. So means in 2.x Hadoop, why we are using multiple masters? At the time of running the jobs, if any master will down or fails, okay, then we can use the second master. So why? Because we discussed right that day in Hadoop architecture, master machine is the very important service. Okay. Why? Because what is the use of master actually that day we discussed, right? What is
It
the use
contain the
of master?
metadata.
Yes, good. It contains the metadata information. So metadata information means data about data,
Data,
right?
yes.
So whenever we'll put some data into cluster, okay, the data first it will receive by master machine. Then master will divide the data into small blocks.
Yes.
Yeah. Why? Because in basically Hadoop it is a distributed file system. In Hadoop, the total data stores in the form of small files, blocks,
Right.
and each and every block size it is 64 MB by default, right?
Right.
Yeah. So this is the default size. But if you want to increase your block size greater than 64, or if you want to decrease less than 64, you can configure. But whenever you didn't configure anything, by default you take 64 MB,
64.
right? Yeah. So master mission will receive the data and you divide the data into number of blocks. Then you distribute the blocks into all available slave missions. Okay. Just a second.
Yeah, I get this point on that day.
Yes. Yeah. So this is the master, and these are the three slaves we have. So here we are putting 190 MB of data. This 190 MB of data is received by master and divide these in three blocks: B1, B2, B3, 64, 64, 64. Then master will distribute these three blocks into three different slave missions: B1 into first mission, B2 into second mission, B3 into third mission. Okay. So here, as a developer, okay, as a developer, we don't know which block stores in. Okay, we don't concentrate on which block is storing in which mission. That is no need actually. As a developer, our responsibility is what? Best put the data into Hadoop cluster. After putting the data, master will receive and it will divide the data into blocks and then put that blocks into different slave mission. That will take care by master mission. Okay, so here B1 stores in first mission, B2 in the second mission, B3 in the third mission. After putting the data, now I'm running some MapReduce job. Okay, so
Mm-hmm.
MapReduce basically it is a parallel processing framework. So whenever you will submit the MapReduce job, the MapReduce it will execute the job on all the slave missions parallelly. Why? Because our input data is available in three different slaves. Okay, so whenever you will submit the MapReduce job, the MapReduce will go and work on different slaves parallelly. So here, yeah, at the time the MapReduce job, it is running the executing the job on first mission, second mission, third mission. So in first mission, after completion of the 50% of the job, my first mission was failed. Okay, my first slave mission was failed, but still job not yet completed. It completed
Mm-hmm.
only 50%. Still 50% is remaining, but mission was failed. Right. So
Mm-hmm.
and second mission, third mission, MapReduce job is running. Now, if map will not get proper results. Why? Because in first mission only 50% job completed, and there is some data is that uh, we will not get proper results. So in these situations, how we can handle this type of situations, this type of problems. In Hadoop, there is a one concept called replication. Okay, replication. So replication means, whatever the data we are putting into the cluster, the same data, it is replicated into some other missions, some other slave missions. The default replication value in Hadoop, it is 3. Okay, the default replication value is 3. So 3 means here putting 3 blocks, right? So this data will be going to replicate again 3 times. So total 3 into 3, total 9 blocks. Actual blocks is 3 blocks only. Means actual data is 192 MB. But this 192 MB of data is going to replicate 3 times. So 192 into 3, right? So this 192 is 3 blocks, B1, B2, B3. So again, it is replicated 3 times. Total 9 blocks. So see here, B1 into first mission, B2. First copy is going to first mission.
Yes. Mm-hmm.
So this is our first copy. This B1 here, okay, and B2 here. and being failed here. This is the first copy, and second copy is this one, B1 here.
Yes, I got it, because every time they have to run in parallel, it means at any moment of time, one node will be getting only one kind, like either B1, B2, and B3. But it can be in any slave.
Yes,
Yeah.
but if you
Okay.
observe here, same copy of log never
Yes.
stores in the same mission.
Yes.
Compulsory will store in different mission. Why? Because if
Exactly.
suppose, yeah, if suppose in these three copies, B1 stores into first mission, and second copy of B1 also stores in first mission, and third copy of B1 also stores into first mission. Okay, three B1 copies are in the same mission. If that mission fails,
B1
three
will be.
copies,
Yes.
yeah, there is no use of replication, right? At that time,
So how we control we did that, like B1 should not be in the slave one.
sorry.
So next time when we run uh,
Hmm.
replication, then how do we ensure that B1 is now slave in the slave 2 instead of slave 1?
Yes, yeah, that is known by master mission, right? Master mission having the metadata information already.
Okay.
Okay, so whenever slave one fails, actually, in between master and slaves, there are some network signals are available. Each and every 10 seconds, all slave missions send signals to master. Okay, so based on the signals, master understood that particular slave is working. If suppose master did not get signal from any particular slave after 10 seconds, then master understood the slave is not working. Then it will check immediately what is how much data is there and what blocks are there, how much data is there. Is there any job is running? If job is running, then it will check the same copy of block is available which slave. So based on that information, immediately master submit that job to another slave. Okay.
Okay.
Yeah. And one more point here. Now in first mission, the MapReduce is working on B1. Okay. And same copy of B1 is available in second mission and third mission. So if if slave one failed, then master will choose either second mission or third mission. It will choose which mission first. So again, it will check, is there any job is running? If it is running, if you see here in second mission, 60% of job is completed, and third mission, 80% of job is completed. Then master will choose obviously third mission. Why? Because compared to second mission, third mission is running some fast, right? Here 80% job is completed, still 20% only remaining. So after completion of 20%, then it will execute the failed mission job.
At this point, I'm not able to get why only 80% and 60%. Why
Yeah, that
can't
is
100%?
yeah, just I'm telling some example. Means not 60% means actually MapReduce job is running on first slave, second slave, third slave, right?
Yeah.
It is running on parallelly.
Yeah.
Here in first mission, MapReduce completed 50% job. In second mission, it completed 60%. Actually, it have to complete 100%, but still
Yeah.
it is running, not yet
Okay.
completed. Okay, still it is
Okay.
running 60%. In third mission, it completed 80%. Still complete 20%. Still have to complete 20%. But here our first mission was failed. Then
Okay.
master will submit this failed job to either second mission or third mission. Why? Because same copy of B1 is available second and third, right? Okay. Mukta, are you clear?
Yeah. I think it's only an example when the job is failed before 100%. Generally, the job should be
Yeah. So
expected to do the 100%.
yeah, obviously 100%. But
Mm-hmm.
here, this first mission only 50% completed. Job mission
Mm-hmm.
was failed. Then master submit the first mission job to either second or third.
Mm-hmm.
So
Mm-hmm.
here we have two missions. In these situations, master will choose which mission, second
Mm-hmm.
or third. So
Mm-hmm.
in second mission, only 60% job is completed. Still, it have to complete 40%, right?
Right.
In third mission, it is completed 80%. Just still have to complete it 20% only.
20%.
So
Right.
compared to second mission, third mission is running some executing some job is fast.
Yeah.
So obviously, then master will submit failed job to third mission.
Okay. It's an additional job.
Yes, additional failed mission job.
Okay. Okay.
Okay. So based
Understood.
on yes, so master will check how much percentage job is completed in second mission, third mission. So based on that performance, it will submit that additional job to that particular machine. The master only decides. As a developer, we don't bother about all these things actually.
Okay.
Everything will take care of the master. Master is the important service. Okay. So, and whenever we want to set up the Hadoop cluster, okay, compulsory, obviously we have to choose which mission having high configurations. We have to choose that mission as a master. Better to choose that mission as a master. Why? Because master is the important service, obviously. Okay, everything will take care of a master mission. So, and we have to maintain high configurations for master mission. That is the better.
Okay.
Okay, so actually in my present company we have 15, okay, 15 node cluster, and you know each and every mission configuration it is 64 GB RAM, 2 TB hard disk. Okay, and in these 15 missions we have three masters and 12 slaves.
Okay.
Okay, 3 slaves means actually you know in Hadoop we have 5 different services. The services are name node, data node, secondary name node, job tracker, and task tracker. So job tracker actually in 1.x Hadoop we call it as job tracker, and in 2.x Hadoop we call it as resource manager. Resource manager. Okay, and this task tracker we call it as node manager. Okay, so yeah, here in this these are the 5 important services. We call it as daemons actually. So daemons means, you know, these are running background in Hadoop cluster. So whenever we run the jobs on Hadoop cluster, these services are running background internally. That is the reason we calling it as daemons. So these are the 5 important daemons, and these are the 5 daemons. In these 5 daemons, here 3 are the master services, 2 are the slave services. Name node, secondary name node, and resource manager. These 3 are the master services. So at the time of cluster setup, we'll configure these 3 services into master missions. Okay, and data node, and node manager. These 2 services are the slave services, and at the time of cluster setup, we'll configure these services into slave missions. Okay, so that is in my company we have 3 masters, right? So we configure in one master we configure name node, and another master we configure secondary name node, and another master we configure resource manager. Total 3 masters. Okay, and 12 slaves, and each and every slave compulsory having 1 data node and 1 task tracker. I will show actual article like this. See here I have 2 masters. This is the one master and this is the unmaster. In first master I have name node and job tracker. Second master I have secondary name node. Okay, and here I have 3 slaves. In each and every slave I have 1 data node, 1 task tracker. Data node, task tracker, data node, task tracker. This is the actual Hadoop architecture. In real time, we'll configure Hadoop cluster like this. Okay, clear?
Yeah. So it means at least there should be 3 masters should be there in any.
Yes.
Or 2 clusters.
Yeah. Obviously, that is our wish. If we have additional missions, we can configure. Actually, here in one master we configure name node job tracker. Okay. In my case, I configure name node in one mission and job tracker in another mission. If suppose our system configuration is very high, okay, in that situations we configure 2 services into single mission. That is not a problem. Okay.
Okay.
Clear? Okay. Any doubts?
So yeah, in slave 1 these are 2 machines in the slave 1, or is it a one machine having both these on the same machine? Slave 1 task, data node, and
No.
task
This is the
cluster.
only one. This is the only one mission. But data node and task tracker are the 2 services configured in only one mission.
Okay, so
Okay.
according to my
Slave
understanding,
1.
there are 3 machines for the slave, and 2 machines for the master, according to this figure.
Yeah, exactly, obviously. But for
Okay.
one cluster, we can add n number of slaves, okay? Based on our requirement. Okay, here actually I have total 5 missions, 2 masters, 3 slaves.
Yeah.
Okay,
Yeah.
but if your data size is your client data is very high, then
Hmm.
you can add 3 nodes, 4 slaves or 5 slaves or
Yes.
n number of slaves.
So, so in if we are adding more masters, so it means they are only controlling for slave, like the same. And these are the 3 type of duties, but they are going to perform. The number will be increased, like one master performing these duties for these slaves, then another clusters for the another master, another slave doing the same duty. Is that right?
No, not like that. Okay, not like that. Yeah, we have 3 masters, but
Hmm.
all 3 masters
Hmm.
controlling all the slaves. Okay, now.
Only these
So
5, only these 3 slaves, na? Not more than that. If another slaves come, then we need to have another masters. This is what I'm asking.
no, no,
The
no, not
size
like
is
that.
big.
No, if we want to add some other slave, okay, no need to add one more master. Are you getting my point?
Yeah,
For
I
one
get this
class,
point. We can add number of slaves in this master, but I'm asking if we have number of more, if we have 2x architecture, we have multiple masters, multiple
mm-hmm.
slaves. So in that case, what will be the value of another master?
Yeah. So actually here we have 3 different services, master services. One is name node, another one is job tracker, resource manager, another one is secondary name node. Okay. In one.x Hadoop, all these 3 services, all these 3 master services configured in only one master. Okay. But in 2.x Hadoop, they configured name node in one master, job tracker in another master, secondary name node in some other master. 3 masters only. But you can add n number of slaves. So if you want to add another slave, okay, at that time you have to do the configuration in any one of the master. Hello?
Okay. But what about if I want to add one more master?
But even no need is right. One more master is no need. Why? Because you have only 3 master services: name node, job tracker, secondary name node. You can't get 3 masters, but there is no more master services, right? Only three master services. You can't get 3 missions. That's enough, right?
So whatever be the data, like whatever will be the size of data, always we have 3 masters.
Yes, 3 masters.
Okay. So
Okay,
multiple
3
master
masters,
means,
but multiple slaves. Multiple master means this one only. This is the one master, and this is another master. In first master we have name node and job tracker. Second master we have secondary name node. 2 masters we have. Multiple means more than one. Hello, hello, Mukta. Hello, hello. Hello.
hello?
Yeah, Mukta, can you hear me?
Yeah, now I can hear you. I think the connection was disconnected.
Okay. Yeah. So multiple master means we have 3 master services. For 3 services, we configure 3 masters. That's it. Okay. Why?
Okay.
Because whenever we put some data into cluster, the data stores into slave missions, not into master missions. So
Yeah.
at that time, obviously we have to increase the number of slaves only. No need to increase the number of masters, right?
Right.
Yeah.
So multiple master means then.
Multiple master means, yeah, just a second. Actually, 3 master services we have. I discussed with you in Hadoop architecture. There are 3 master services. One is name node, one is resource manager, and another one is secondary name node. So at the time of cluster setup, we'll configure like this. So these are my master missions. This is the one master, and this is the second master, and this is my third master. So what are the master services we have? 3 master services. One is
name node,
and
job
another
tracker,
one is
job tracker,
job tracker or resource manager, and third one is secondary name node.
Secondary name.
Yeah. So these are the 3 master services. I configured in 3 different masters. So now this is the first master, this is the second master, and this is third master. 3 masters. Obviously, it is multiple masters only, right?
Okay.
If we have one more master service, at that time we'll add one more master.
Okay.
But in Hadoop architecture, we have only 3 master services. These are the 3 master services: name node, job tracker, secondary name node. So that is the reason we are configuring 3 masters only. But
now I get it.
Okay. So whenever put the data into cluster, obviously the data stores to the slave mission. So every time we have to add slaves only. No need to add masters.
Okay.
Yeah. So this is clear, right? Any more doubts?
No, thank you so much. Clear.
Yeah. Thank you. And today we'll stop here, and tomorrow class will continue. What are the different ecosystem components available in Hadoop, and what is the use of each and every component we'll discuss. Then we'll discuss the Hadoop architecture. Okay, and Hadoop architecture, master slave architecture, and what is the use of each and every service like name node, data node, job tracker, task tracker, and the secondary name node. We'll discuss these things. Architecture is important. Okay.
Okay, so we can even continue for today because it's only 30 minutes.
Yeah, but actually I started 9:30, right? 10:30. I have another class. That is the problem. Okay.
Okay, that's
10,
okay.
yeah, actually it is 10:24. At 10:40 I have another class, another demo I
Okay.
have actually. Tomorrow onwards I will continue more
So
time.
when we are doing installation of Hadoop.
Yeah, once the theory of HDFS and MapReduce will complete, then we'll start the installation. Okay. Maximum we'll plan the installation on weekends. Weekends means Saturday or Sunday. Why? Because installation will take 2 hours time. So mostly I will plan on weekends. Okay.
Okay. So could you please send me the email for the syllabus?
Yes, sure. I will forward. Actually, I already sent to GPS Infotech. That guys will send. Otherwise, you can give me the mail ID. I will send.
Okay. So should I wait
Can
for
you,
them, or I can tell you about my email ID?
yeah, you can put your mail ID in chat box. I will send.
Okay.
Hello.
Hello.
Yeah, Mukta, are you typing?
I don't know where I need to type. I was just looking. Is
Yeah.
it a
In this, there is a chart is right.
chat?
Yeah, you click on chart, and under the
Okay.
chart there is a box will come. I will send a hi message. Yeah, okay, I got it. Okay, I will send the course content again. Okay.
Okay. Thank you so much.
Okay, thank you. Thanks for joining. We'll meet tomorrow. Okay, bye.
Okay. At 9:30?
Yes, 9:30 p.m. IST. Same time.
Yeah. Okay.